Good morning to all of you. Let's start the class. New chapter, chapter 12, parallel lines. Let us draw two straight lines AB and CD as shown in the figure first. We find that these lines, when produced towards the left, meet at a point O. Here you have seen in this figure, AB and CD, when produced, it meet at a point O. Again, let us draw straight lines PQ and RS as shown in the figure second. These lines, when produced towards the right, meet at a point M. Here you've seen in this figure, these two lines, when produced, become meet at a point M. However, there are examples of lines which, when produced indefinitely in either direction, do not meet. Such lines are known as parallel lines. The opposite edges of blackboard, the opposite edges of a ruler, railway lines, etc. are all examples of parallel lines. Here you have seen in the example, opposite edges of the blackboard, opposite edges of the ruler, railway track, all are the example of parallel lines because they never meet at any point. Parallel lines, its definition: two lines in a plane which do not meet even when produced indefinitely in either direction are known as parallel lines. It means two lines which never meet at a point when produced. Then it is a parallel line. If L and M are two parallel lines, we write L parallel to M and read it as L is parallel to M. So L is parallel to M or M is parallel to M. Both are correct. Here you've seen in the figure, this two line L and M, both are parallel, and you have to write L, symbol of parallel, to the M and read as L is parallel to M. Or you have to write M is parallel to L is also correct. Distance between two parallel lines. Let us draw two lines L and M such that L is parallel to M. Take any point A on one of these lines, say L. At A, draw AD perpendicular to L, meeting M at D. Measure the length of the line segment AD. This AD is called the perpendicular distance between the L and M at a point A. Here you've seen in this figure. Let us take any other point B on L. See this figure. B is here. From B, draw BC perpendicular to L, meeting M at C. Measure the length of the line segment BC. We find that AD is equal to BC because of the distance between them are same. Thus, the perpendicular distance between L and M at the point A is same as that at B. Actually speaking, the perpendicular distance between two parallel lines is the same throughout. This distance is called the distance between two parallel lines. Thus, parallel lines are the same distance apart throughout. Why railway lines are made parallel? The wheels of a railway engine and those of the bogies are attached by axles of a fixed length. So the distance between each pair of opposite wheels remains fixed. Therefore, the rails on which these wheels roll must be at a constant distance from each other. Hence, the opposite rails must be parallel. Parallel segments and parallel rays. Two segments are parallel if the corresponding lines determined by them are parallel. See the figure 1. Two rays are parallel if the corresponding lines determined by them are parallel. See the figure number 2. One segment and one ray are parallel if the corresponding lines determined by them are parallel. See the figure number 3. Now consider the following questions. If two segments do not intersect, are they parallel? If two rays do not intersect, are they parallel? If a ray and a segment do not intersect, are they parallel? See the figures given below every figure. In the figure first, we observe that the segments AB and CD do not intersect, but the corresponding lines determined by them will clearly intersect. So the segments AB and CD are not parallel. Similarly, in the figure second, the rays AB and CD do not intersect, and yet they are not parallel. And in the figure third, the segments AB and the ray CD do not intersect, but they are not parallel. Thus, we conclude that if two segments do not intersect, we cannot say that they are parallel. The same is true for two rays as well as for one ray and one segment. How to test whether given lines are parallel? By using set squares, we can test whether the given lines AB and CD are parallel or not. We proceed in the manner given below. Method: place the ruler so that one of its measuring edges lies along the line AB. Hold it firmly with one hand. Now place a set square with one arm of the right angle coinciding with the edge of the ruler. Draw the line segment PQ along the edge of the set square as shown in the figure. Here you've seen PQ. Slide the set square along the ruler and draw some more segments RS and LM as shown in the figure. So you have to draw some more RS and LM line segments. If PQ, RS and LM is equal, then AB is parallel to CD. If all are equal, that means AB is parallel to CD. Otherwise, AB is not parallel to CD. Now, come to the exercise 12. Question 1. In the figure of a table given below, name the pairs of parallel edges of the top. Parallel edges. Which one is parallel? This is parallel to this one. That means AB is parallel to CD. Next, we have to take this one. That means AD and BC are parallel edges. This will be your answer. Now, see the question number 2. Name the groups of all possible parallel edges of the box whose figure is shown below. You have to write all the groups of parallel edges. So, how we have to do? I have to take AB. Its parallel is HE, its parallel is CD, its parallel is GF. These all are parallel to one another. Okay, now take other part of it. That means this side. Okay, that means CF is parallel to DG, parallel to BE, parallel to AH. Okay, like this you have to take this one, CB parallel to EF, parallel to GH, parallel to DA. You have to write all the parallels which are given. So do this by your own. Okay, now some more questions. Question 3. Identify parallel line segments in each of the figures given below. You have to identify the parallel lines. So you have seen here D is parallel to BC. In this figure, DC parallel to AB and DA parallel to CB. Okay. In this figure, which one is parallel? RS parallel to PM. This one is parallel to this one. This one is parallel to this one. Question 4. Find the distance between the parallel lines L and M using a set square. Use the set square and find the distance. Question 5. In the figure, L is parallel to M. Here you have seen in the figure, L is parallel to M. If AB is perpendicular on L and CD is perpendicular on L and AB equal to 2.3, find CD. You know that if both are perpendicular and lines are parallel, then it means its measurement is also same. So the value of CD is also 2.3. Okay. Question 6. In the figure, do the line segments AB and CD intersect? No. Are they parallel? No. So you have to write its give reason for your answer. Corresponding lines which never intersect when produced in one direction. Question 7. Using a set square and a ruler, test whether L parallel to M in each of the following cases. So do it by your own. Here you have seen with figure they are parallel because distance is same. So this is parallel. But here you have seen distance is different. That's why this is not parallel. You have to use the set square and ruler, you will get the answer. Question 8. Which of the following statements are true and which are false? Two lines are parallel if they do not meet even when produced. Two lines are parallel if they do not meet when produced. That means this definition is correct. That is first part is true. Second, two parallel lines are everywhere the same distance apart. Yes, true. Two line segments do not intersect, they are parallel. False. Two rays do not intersect, they are parallels. False. So do the homeworks of this exercise, all the questions which are remaining as an homework. Thank you.